A message broker is a software intermediary or middleware that facilitates communication and exchange of messages between different applications or components in a distributed system. It acts as a central hub or mediator for sending, receiving, and routing messages, ensuring reliable and efficient message-based communication. Here are some key characteristics and functions of a message broker. 1. Message routing. A message broker routes messages from senders, producers, to their intended recipients, consumers. It determines the destination of each message based on predefined rules, such as message attributes, content, or routing keys. 2. Message queuing. A message broker typically uses message queues to store messages until they are consumed by the intended recipients. Queues provide a temporary storage mechanism that decouples the sender and receiver, allowing asynchronous communication and ensuring reliable message delivery, even if the sender and receiver are not available simultaneously. 3. Message transformation. Message brokers often provide capabilities for transforming messages between different formats or protocols. For example, a message broker can convert a message from one data format to another to facilitate interoperability between applications that use different communication protocols or data formats. 4. Message filtering and routing. Message brokers can filter and route messages based on specific criteria. They can examine message attributes or content and selectively deliver messages to different queues or subscribers based on predefined rules or patterns. This allows for flexible message routing and targeted delivery to specific consumers. 5. Message persistence. Message brokers may provide mechanisms to persist messages to disk or durable storage to ensure message durability and prevent data loss. This is especially important in scenarios where messages need to be stored and retained for a longer duration or in the event of system failures. 6. Message acknowledgement. Message brokers often implement acknowledgement mechanisms to ensure reliable message delivery. Consumers can send acknowledgements back to the broker after successfully processing a message. If a consumer fails to acknowledge a message, the broker can requeue or handle the message based on predefined rules, such as retrying delivery or sending it to a dead letter queue. 7. Scalability and load balancing. Message brokers are designed to handle large message volumes and provide mechanisms for scaling horizontally. They can distribute messages across multiple nodes or instances, allowing for load balancing and improving overall system performance and throughput. 8. Protocol support. Message brokers support various communication protocols, such as AMQP, Advanced Message Queuing Protocol, MQTT, Message Queuing Telemetry Transport, or proprietary protocols. This enables applications developed in different languages or using different technologies to communicate seamlessly through the broker. Certainly. Here are some additional details about message brokers. 9. Publish-subscribe model. Message brokers often implement a publish-subscribe messaging pattern. In this model, publishers send messages to specific topics or channels, and subscribers express interest in receiving messages from those topics. The message broker handles the distribution of messages to the subscribed consumers, allowing for one-to-many communication. 10. Request-reply pattern. Message brokers can also facilitate the request-reply pattern. In this scenario, a client sends a request message to a specific destination, and the message broker routes the request to the appropriate service or application. The service processes the request and sends a response message back to the client via the message broker. 11. Message transformation and enrichment. Message brokers may provide features for transforming or enriching messages as they pass through the broker. This can include modifying message headers, adding additional metadata, or performing data transformations to ensure compatibility between different systems or components. 12. Guaranteed delivery and reliability. Message brokers often offer mechanisms to ensure guaranteed message delivery and reliability. They can provide features like message acknowledgement, durable message storage, and retry mechanisms to handle failures or network interruptions. This ensures that messages are not lost and that they are reliably delivered to their intended recipients. 13. Message prioritization. Some message brokers support message prioritization, allowing the sender to assign different priorities to messages. This enables the broker to deliver high-priority messages before lower-priority ones, ensuring timely processing of critical messages. 14. Scalability and fault tolerance. Message brokers are designed to be scalable and fault-tolerant. They can handle increasing message loads by distributing messages across multiple nodes or instances. If a node or instance fails, the broker can seamlessly redirect messages to other available nodes, ensuring continuous message processing and minimizing downtime. 15. Monitoring and management. Message brokers often provide monitoring and management capabilities. They offer tools and interfaces to monitor message queues, track message throughput, manage subscriptions and consumers, and configure various broker settings. This helps administrators gain visibility into the messaging system and ensures efficient operation and maintenance. 16. Security and access control. Message brokers typically offer security features to protect message communication. They support authentication and authorization mechanisms to ensure that only authorized clients can send or receive messages. Access control policies can be implemented to restrict message access based on user roles and permissions. 17. Integration with other systems. Message brokers can integrate with other systems and technologies. They often provide client libraries and APIs for various programming languages and frameworks, allowing applications to connect and communicate with the broker easily. Additionally, message brokers may offer connectors or adapters to integrate with external systems like databases, cloud services, or other messaging systems. Message brokers are widely used in various industries and applications, including enterprise systems, microservices architectures, IoT platforms, real-time analytics, and event-driven systems. They provide a flexible and reliable foundation for building distributed and loosely coupled systems that can handle large-scale messaging and communication requirements.